Today is the day before Halloween, and I'm glad everyone has joined. Thank you, Aaron, for turning on your camera. Um, so if you'd like to please join the Kahoot and post in the chat, that'd be great. So we can get started later down, class. Um, Today we're actually going to be learning something called the distributive factor, which you'll see a lot when you get to high school math. Actually, like later on in math, it's very difficult for you to not see the distributive property. But before we do that, we're going to have to learn something called greatest common factor. So do I have any volunteers here who know what greatest common factor is? So without looking at the screen. Pretend you haven't seen my screen and you're like, what is greatest common factor? Okay, Ryan, go ahead.
So the greatest common factor is the greatest factor when you between two or more numbers.
What does that mean? So if I gave you two numbers, for example, how would you find the greatest common factor?
Just by knowing the factor, like you just divide them by one, like just divide them by each number, and yeah.
Okay, why would you divide them by each number though? So what's your reasoning behind it?
So I can know if this number can be divided by another number.
Okay, so you want to see which numbers are divisible by each other, basically. Is that
Yep.
what you're trying to say? Okay, I think you're going to a great start. But over here we see that the greatest common factor of two numbers is the greatest number that is a factor of both of them. That probably doesn't say much about them, but let's look at an example. I think once you guys see an example, you'll realize that you realize what it actually means. Okay, so here they gave us two numbers, 12 and 18, and if you go down the number line, there's only like 11 numbers under 12, and we see that these from 1 through 6, all these numbers divide into 12, and from 1 through 9, these five numbers divide into 18. But if we compare, we see that 6 appears in both lists, right? I don't think I can highlight it properly, but we see that 6 appears in both lists. And because it's the biggest possible number you can get, it's the greatest common factor. So over here, we see that 6 would be the greatest common factor that 12 and 18 have in common. Do you guys have any questions? Or should we do some practice questions first? Okay, well, let's look at 8 and 14. Can you guys all annotate on the screen? So, okay, let's let's write these numbers down. Um, if we uh if we look on the screen, we have two numbers. There's 8. Oops, we have 8 and we have 14.
Hello.
Hi, Jason. So right now I'm trying to find the greatest common factor between 8 and 14. Okay, so can everyone tell me what numbers divide 8? Okay, let's start
One,
with this number. 1. Thank you, Ryan.
two,
Um,
4, and 8.
okay, I'll go down the list. So, Sean, can you tell me what other number
Go
other than
back
1 divides into 8?
Can I say
Okay, Jason, go ahead.
8, 16, 24,
Oh, okay,
32,
Jason,
36.
you're listing the multiples of 8. So you're listing what 8 can divide itself,
Oh, so
right? I'm
one,
asking for numbers that divide 8.
oh, 1, 2, 4,
Okay, so we have 1, 2, and 4,
and 8.
and 8 itself, obviously. So 1, hit a comma, 2, 4, and 8. 8. Perfect. Someone other than Ryan and Jason. Ryan Lin, would you like to try to find the factors of 14, please? Ryan Lin. So what numbers divide 14? You can start with 1, right? So there's 1, Does 2 divide 14?
What?
Does 2 divide 14, Ryan? So like if you took 14 divided by 2, would you get an answer, an integer? So what's 14 divided by 2?
14 divided by 2. Okay, let's see. 7?
7. Okay, so we know that both 2 and 7 divide 14, right? So we have 2, and then somewhere down the line we have a 7. Does 3 divide 14? Ryan?
Hmm.
You can say yes or no, or if you don't know, just say you don't know.
No.
I don't think so. So 3 doesn't go into 14, right? Because if you try, for example, 14 divided by 3, 14 divided by 3, you can put a 4 on top because 3 times 4 is 12. So we have 12. But then you have 14 minus 12 is 2. And 3 can't go into 2. It's like trying to put a big fat boy into a tiny little hole. It's very hard. It's very hard to put it in. So if you have three things, you can't put it into 2 holes, right? Or that's not a very good example, but you see that 3 doesn't go into 2. So because of that, we know that 3 doesn't divide 14. Does 4 divide 14, Ryan Lynn?
What?
Does 4 divide 14? So instead of a 3, what if I switched it into a 4?
Hmm. Let's see. Hmm. Hmm.
So 14 divided by 4. Does 4 divide 4? Does 14 is 14 divisible by 4?
Hmm. Yes.
Yes or no? So what is what is the biggest number you can think of? So okay, let's try this. What is 1 times 4?
1 times 4 is 4.
2 times 4 is
8.
8. 3 times 4 is
What?
3 times 4. So what's 3 times 4?
12.
12. What about 4 times 4?
4 times 4 is 16, I think.
16. So we see that we can't put a 4 on top because if we put a 4 on top, we'd have a number that's too big on the bottom. So we can only put a 3, right? So over here, we have 3 times 4. So 3 times 4, just said, was 12. And we have the same problem. 14 minus 12 is 2, but 4 doesn't go into 2. So 4 also isn't divisible. 4 also, 14 is not divisible by 4 either. Um, and actually, we could have seen something, which is that when we saw the 2 and the 7, um, we see that 14 is equal to 2 times 7, right? And what do you know about 2 and 7? 2 is only divisible by 2 in itself, right? Divisible by 2 and 1. And 7 is also only divisible by 7 and 1. Both of these are prime, okay? And once we break 14 down into its prime divisors, we only know it can only be divided by 2 and 7, okay? So at this point, we know that 14 is obviously divisible by 1, it's divisible by 2, it's divisible by 7, and it's divisible by itself. So let's look on the list. 8 and 14, they're both divisible by 1. That's what's common with all integers. And they're both divisible by 2, right? But if we look in the list with 8, there's a 4. 14 does not have a 4. It has an 8. 14 does not have an 8, but 14 has a 7 and has a 14. So the greatest common factor here would be a 2. You guys see that? If we list all the factors of 8 and all the factors of 14, we see that the greatest common factor is a 2. So if we go back to our example here, let me just erase everything on the screen. We know that the greatest common factor is a 2. Let's try that. So here, let's try a 2. We check. Ding. We got the answer correct. Would anyone like to try and find the greatest common factor of 15 and 30? Any volunteers? Aaron? You can draw on the screen if you'd like, or you can just say the answer in the chat if you know the answer already. Okay, I see Aaron's writing on the screen. I'll write 30 for you if you need my help. Or actually, Garrus, can you write the factors of 30, please? Under Aaron's 15 on the screen, if that is possible. Okay, so Aaron has factors, is listing the factors. 15 is divisible by 1, it's divisible by 3, it's divisible by 5, good. Okay, Garrus is also starting. We have 30 is divisible by 1, 2, 3. I think that's a 6, if I'm not mistaken.
Oh, wait, that was the 30.
That's a 30. Sorry. So you know it's divisible by 1, divisible by 2, divisible by 30. And Aaron, I
Yeah.
think you've written 1, 3, 5, 15, 5, 3. Okay, so just to make it clear, if you already wrote the factors once in the list, you don't need to write it again. Okay, so this 5 over here and the 3 over here, they're redundant, so to speak, which means you don't need to write it again in a list. Okay, so you can erase that, Aaron. Maybe a bit much, but yeah. So I'm pretty sure you got most of the factors. You got 1, 3, 5, 15. Those are the factors of 15. Yours, you had a great start. You had 1, which you should always start with. Have you tried dividing 30 by 3, Iris?
I already wrote that.
Okay, so
that
you have 30. You have
for thinking.
3. Okay. So something with factors is that usually they come in pairs, okay? So when you divide 30 by 1, what's the answer, Garrus? So what's 30 divided by 1?
30 divided by 1 should be 30.
Exactly, it should
What?
be 30. So 30 divided by 1 is just 30. What about 30 divided by 2?
15.
15. What about 30 divided by 3?
10.
30 divided by 3 is 10. Okay. So we see that as the factors keep on growing on one side, these factors they start shrinking on the other, right? So you don't need to, go through every single number. You can pretty easily see that some of the bigger factors, you can find them right away just by dividing them by smaller factors. Okay? You can keep going. So what's after 3? Can you divide it by 4? Can you divide 30 by 4? Yours?
Wait, let me just think for a second.
Jason, you want to say something?
Yeah, you cannot divide by 4, but you can
You
divide by
cannot
5.
divide by 4.
So, but you
You
can do
can
it by
divide by
5.
5. Okay, excellent.
Also 6.
Also 6. So I think that is most of the numbers because
It's
you see, once
6:15.
we know 4 doesn't work, but 5 works, right? And because 5 works, we get a 6 because 30 divided by 5 is a 6. And if we move on, right? If we try a 6, then this entire list just flips, right? We had 1, 2, 3, 5, 6, and then if we keep on going up and putting in numbers, we're going to get this list. So just by finding every single number up to approximately the square root of 30, if you know what that is, you can find all the factors pretty quickly actually. So just by listing the factors, let's see if we can find the greatest common factor. Jason, you want to give it a try? Let me just erase some of this to make it more accurate. So what is the greatest common factor, Jason?
What?
What is the greatest common factor between 15 and 30? So can you show me how you would find it using this
5.
format?
I
You
mean
think
15, 15, 15.
it's 15. So just doing it the slow way, we see that obviously they both share 1, right? They also both share 3. We see a 3 in both lists. They also share 5. And then 15 is divisible by 15. So the 15 is shared in both lists. And you could have actually spotted this really quickly when, you can, if you can just do the division. If you try 30 divided by 15, if, you have enough experience with these things, you know that 30 divided by 15 is 2. So these numbers are divisible. So
Just
in
to
this
make
case,
sure, GCF means greatest common factor, right?
exactly. So that's actually going to be a question on the Kahoot, and you'll see it pop up very, very often when you study number theory, actually. So I'll clear all the pictures on the screen, and we can type in the answer here. Answer should be 15 because we just found the answer to be 15. And the answer is correct. Let's move on. Oh, okay. Now we have 3 lists. This might look very complicated, but Henry, would you like to tell me what are the factors of 7? I'll write all 3 numbers out. We have 7, we have 21, and we have 70. Henry? So can you please tell me the factors of 7, please? So what numbers divide into 7? Okay, Jason?
Because only one, or we can have like a fraction.
Not exactly. You are
I
correct.
mean decimal. I mean a decimal.
We're not touching decimals here. When we're playing with number theory, we pretend decimals and fractions they don't exist. Okay?
Okay, then that it's only one.
Only 1 and what? What about 7? Does 7 divide itself?
Yeah.
Yes. So both 1 and 7 are factors of 7. What about 21?
21 is 1,
Hmm?
not 2,
Not 2. 2
3,
doesn't work yet because
3.
we know that 1 is not divisible by 2. What about 3? Okay.
Yes.
So what's 21 divided by 3?
6.
21 divided by 3 is 6?
No, no, no. 7.
7. Okay. So 21 divided by 3 is 7. If you do go
Yeah.
like, aha, 23 divided by 1 is 6, you can check this, right? By saying, what is 3 times 6? So what is 3
21.
times 6, Jason?
18.
18. And I don't think we did 18 divided by 3 before, right? It was 21 divided by 3. So 21 divided by 3 is 7. So we can put a 3 here. And since 4, 5, 6, none of them divide 21, we can also put a 7 here. And then,
No 8.
well, we don't need to test 8 anymore. Do you want to know why?
Because, yeah, because 8 is an even number and 21 is an odd number. And an
Right.
even number
So
cannot
that's
go.
true. That's true, Jason. But remember, the little trick I taught you, where, for example, you start with 1, right? And after you divide 21 by 1, you get 21. What if you divide 21 by 3?
7.
You get 7. And if you try 4, 5, 6, none of them
The
work.
worst. Oh yeah, because 7 is the highest you can
Yes,
go.
so once you go to 7 again, you're going to get a 3,
And
right?
then
Divide 21 by
21.
7, you get a 3, and then you move all the way down the list. Eventually, you get a 1 again. So in this case, the factors of 21,
Hey, you forgot
1,
21. You got
exactly, I
that
did
21.
forget 21. Thank you. So the factors are 1, 3, 7, and 21 itself. Awesome. What about 70? Okay, Ryan, I'll let you take this one.
So the factor of 70 are 1,
Mhm.
2,
2,
and 5,
5, okay,
7,
7,
and then 10,
10,
and
keep
then
going,
14,
14, wonderful,
and then 35,
35,
70.
finally,
70.
70, awesome. So how did you find these last three numbers? I mean, if I'm pretty sure you didn't go like 70 divided by 13, 17 divided by 14, divided by 15. That would have taken a long time, right,
I
Ryan?
just when I'm at, is near the when I am near the middle, I just divide the 70 by the number in front. From
Exactly.
from from right to left.
Mm-hmm. So in this case, remember we can pair them, right? So let me just erase some of these last numbers. I think I accidentally got rid of something. So at the beginning we tried 70 divided by 1, right? So 70 divided by 1 is just 70. What about 70 divided by 2? I think Ryan, you found that was 35, right? So we know that 35 is a factor. 70 divided by 5. What's that, Ryan?
30 divided by 5,
Mm-hmm.
that's 14.
That's 14. And then 70 divided by 7
10.
is simply 10. Awesome. You can also try 8 and 9 just in case, but I don't think you'll get any answers for those. So we know that the factors of 70 are 1, 2, 5, 7, 10, 14, 35, and 70. So you notice they all come in pairs, right? Come in pairs. So that's something that's very nice when you're trying to find factors of some pretty big numbers. Okay, now back to our answer. I'm gonna ask Jagger. Is that your name? Jagger? Or is it Jaeger? Uh, Jagger, can you help me find the greatest common factor of all of these numbers, 7, 21, and 70?
It's a 7.
It's 7. Why is it 7?
Um, 7 have 7. 21 has a 7.
Mm-hmm.
70 has a 7.
Exactly. So 7 has a 7, 21 has a 7, 70 also has a 7. So in this case, we know that 7 is going to be our answer. Let me just clear the screen for a second. And we can answer this question. So 7 is the answer. Hooray! We got this correct. I think we've got greatest common factors mostly answered. Um, there is actually a pretty fancy way. If I gave you like really, really big numbers, let's say I gave you something like 960 and 420, for example. Those are pretty big numbers, and you don't want to list an entire page full of numbers and find out, oh, the answer was 1, because that can be very annoying sometimes. There's something called the Euclidean algorithm. If you learn programming classes, you might be able to encounter that pretty early on. But it's a very fast way to find greatest common factors without having to do everything we did here. So, uh, I mean, it is very useful when you want to find all the factors of small numbers, this list I think we're doing here. But once, you start doing harder math, make math with bigger numbers, there are going to be some small shortcuts. If you don't know how they work, it's okay, but it is much better when you actually know how they work. I'll cover that in our next lesson. So today we are going to learn the distributive property of addition. We're just going to be playing with real numbers here, no variables for today, but next week we will be starting with variables. So you guys can tell me if you can't hear anything, but I'll start the video.
Rewrite the expression 4 times, and then in parentheses we have 8 plus 3, using the distributive law of multiplication over addition. Then simplify the expression. So let's just try.
Oops, sorry. Bye-bye.
Let's just try to solve this or evaluate this expression, and then we'll talk a little bit about the distributive law of multiplication over addition, usually just called the distributive law. So we have 4 times 8, 4 times 8 plus 8 plus 3. 8 plus 3. Now, there's two ways to do it. Normally, when you have parentheses, your inclination is, well, let me just evaluate what's in the parentheses first, and then worry about what's outside of the parentheses. And we can do that fairly easily here. We can evaluate what 8 plus 3 is. 8 plus 3 is 11. So if we do that, let me do that in this direction. So if we do that, we get 4 times, and in parentheses, we have an 11. 8 plus 3 is 11. And then this is going to be equal to, well, 4 times 11 is just 44. So you can evaluate it that way. But they want us to use the distributive law of multiplication. We did not use the distributive law just now. We just evaluated the expression. We used the parentheses first, then multiplied by 4. In the distributive law, we multiply by 4 first. And it's called the distributive law because you distribute the 4. And we're going to think about what that means. So in the distributive law, what this will become, it'll become 4 times 8 plus 4 times 3. And we're going to think about why that is in a second. So this is going to be equal to 4 times 8, 4 times 8 plus 4 times 4 times 3. 4 times 3. A lot of people's first instinct is just to multiply the 4 times the 8. But no, you have to distribute the 4. You have to multiply it times the 8 and times the 3. This is right here. This is the distributive property in action right here. Distributive property in action. And then when you evaluate it, I'm going to show you in kind of a visual way why this works. But then when you evaluate it, 4 times 8, do this in a different color, 4 times 8 is 32. And then so we have 32 plus 4 times 3. 4 times 3 is 12. And 32 plus 12 is equal to 44. That is also equal to 44. So you can get it either way. But when they want us to use the distributive law, you distribute the 4 first. Now let's think about why that happens. Let's visualize just what 8 plus 3 is. So let me draw 8 of something. So 1, 2, 3, 4, 5, 6. Let me draw it this. Well, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to add to that. We're going to add to that 3 of something, maybe the same thing. 1, 2, 3. So you can imagine this is what we have inside of the parentheses. We have 8 circles plus 3 circles. Now, when we're multiplying this whole thing times 4, what does that mean? Well, that means we're just going to add this to itself 4 times. So let me do that with the copy and paste. Copy and paste. Let me copy, and then let me paste. There you go. That's 2. That's 1, 2, 3. And then we have 4. And we're going to add them all together. So this is literally what 4 times, right? We have it. Let me go back to the drawing tool. We have it 1, 2, 3, 4 times this expression, which is 8 plus 3. Now, what is this thing over here? What is this thing over here? What is this thing over here? If you were to count all of this stuff, you would get 44. But what is this thing over here? Well, that's 8 added to itself 4 times. You can imagine you're adding all of these. So what's 8 added to itself 4 times? That is 4 times 8. So this is 4 times 8. And what is this over here in the orange? We have 1, 2, 3, 4 times. Well, each time we have
It's
3.
6:30.
So 4 times this right here. This right here is 4 times 3. So you see why the distributive property works. If you do 4 times 8 plus 3, you have to multiply when you, I guess you could imagine, duplicate the thing 4 times. Both the 8 and the 3 is getting duplicated 4 times, or it's being added to itself 4 times. And that's why we distribute the 4.
Okay, wonderful. So that was the distributive property in in action for addition. So when we apply the distributive property, we can use it for some pretty complicated mathematics problems. And this is just an introduction. I mean, you could definitely do everything we're doing today just by evaluating the answer directly, but we can break it up so that the answer is easier to get. So, do I have a volunteer who'd like to read this section, please? Hey, Ryan, go ahead.
Breaking up multiplication. This array is made of this array is made up of 3 rows with 6 dots in each row.
Mhm.
The dot shows 3 times 6 equals 18.
Okay, and I'm pretty sure if you count them all, you will get 18. So now, if we add a line dividing the dots into two groups, the total number of dots does not change. I mean, it's just like if you have a banana. If you cut the banana is still a banana. Just because you cut it, it doesn't change anything. I mean, if you ate the banana, that's when something changes. But if you cut the banana, the banana is still a banana. Okay? Okay, Ryan, go on.
The top group have 1 row with 6 dots. The dots show 1 times 6. The
Mhm.
bottom group have 2 rows with 6 dots in each row. The
Mhm.
dot shows 2 times 6. We still have a total of 18 dots.
Okay, wonderful. So we see here that even if we like chop it up into pieces, these dots, it's still 18 dots. I mean, you can cut it up, you can in any way you want, but no matter how you arrange it, it still is 18 dots. And that's the distributive property. Um, it might look very useless right now. I mean, when I learned it, I'm like, holy cow, this is the most useless thing ever. But you'll find that it actually is very useful when you need to manipulate variables. Just in future math courses, it'll save your life basically. So another volunteer, Nicole, would you like to read this part, starting with the distributive property?
Distributive property. The math rule that allows us to break up multiplication problem is called the distributive property.
Okay, keep reading, please.
The distributive property says that in multiplication problem, when one of the factor is rewritten as the sum of two numbers, the product does not change.
Okay. So we see here that when rewritten as a sum of two numbers, it's like breaking a number into two parts, okay? We know that 5, it can be written as 2 plus 3 or 4 plus 1, right? Because 2 plus 3 is 5 and 4 plus 1 is also 5. Nicole, continue, please.
Wait, where do I read up to?
You can read up to here. I'll take over from then.
Okay. Using the distributive property allows us to solve two simpler multiplication problems.
Mhm.
In the example with the dots we started with 3 times 6.
Okay, very good. And we see that there are 3 times 6 dots over here, which is 18. But we're not trying to solve multiplication problems here. I'm pretty sure most of us, or all of us, hopefully, we all know our times tables well enough. But here we see that we can break down the 3 into 1 plus 2, because 1 plus 2 is equal to 3. Yes, Jason? You wanted to read?
No, I wanted to solve.
Oh, okay. Well, you can read the next part, because
Okay.
the
We
answer.
use the distributive property to change the problem from 3 times 6 to parenthesis 1 plus 2
Mhm.
parenthesis times 6. The
Wonderful.
6 gets distributed to the 1 and 2, and the problem changes to parenthesis 1 times 6 plus parenthesis 2 times 6.
Mhm.
Now we need to find the two products,
Mhm.
6 plus 2. And finally,
6 plus 12.
the
Yes.
sum. 6 plus 12 is 18.
Okay. And
3 times 6 equals 18. And 1 plus parenthesis 1 plus 2 times 6 equals 18.
okay, good. So down here, we have which expressions are the same as 4 times 9? Jason, would you
A
like
and
to
B.
try one of them? A? You
A
think
and B.
is the answer? Why
A
so?
and B.
Oh, okay, just answer A for now. Why is A the answer?
Because if you do 4 plus 4, no, I mean 4 plus 5 is 9
Mm-hmm.
times 4.
Okay,
It
good.
was times 9. Yeah.
Awesome. So, Nicole, can you tell me what other answer in this list also works?
Wait,
So it's asking which expressions are the same as 4 times 9.
wait 1 second.
You don't actually need to calculate them, okay? You don't have to go like, oh, 1 plus 8 is 9, and then you multiply by 4 to get it's like 36 or something. But you don't have to do that, okay? You just need to look at what's the difference. You see, there's 4 times 9. That's the first expression. And then over here we have 4 times something. And that's what was this something? Is 1 plus 8? What was that equal to, Nicole?
16.
What 1 plus 8?
Oh, 1 plus 8 is 9.
1 plus 8 is 9. And we see that 4 times 1 plus 8, that's the same as 4 times 9, right? What about C? Is C also the answer? 4 times parentheses 2 plus 5 closing parentheses?
No.
No, why not? Nicole?
5 plus 2 is 7.
5 plus 2 is 7. And 4 times 9 is not the same as 4 times 7. Let's say I wanted to keep the 2, okay? What would you have to change the 5 into so that the expression is the same? Nicole? I'm so
7.
sorry picking on you, but
7.
7? Exactly. So I'd have to change the 5 into a 7 because 4 times 2 plus 7 is equal to 4 times 9, right? So let's check this answer. Hurrah! I think Jason got it correct. Both of these are good. So hopefully we can move on. Is everyone following along?
Yes,
Or
sir.
yes, sir. Thank you. If you need any help, just raise your hand and quickly ask me to go back, review anything you don't need to know. Okay, you don't know. Um, okay. Let me just look at this next problem. This part. Okay, there are some pretty difficult things here. Okay. All right. Let's read this part. William, would you like to read small numbers just from here to here?
Some numbers like 1, 2, 5, and 10 are easier to multiply.
Mhm.
The distributive property allow us to change our multiplication problem so that we can use these numbers as one of the factories. For example, we can change 4 times 12 into 4 times 10 plus 2.
Thank you, William. So we see how we broke the 12 into 10 plus 2 because 4 times 10 that's pretty easy to do, and 4 times 2 that should also be pretty easy to do. And while we're at it, I actually want to introduce a math solving technique that most people they probably ignore. Is that when I give you a problem like 12 times 4, for example, most people they're gonna go like, okay, so 2 times 4 is 8 and 1 times 4 is 4. So 48. This is a perfectly valid way to do it. But if if the number, for example, is bigger, uh let's say I threw in like, well, The reason we do this is because there's something you guys probably know as carrying, right? Like let's say if this was a 3. If we have a 3 times 4, we'd have a 12 here, and then we have to carry the 1. And then 1 times 4 plus 1 is 52. So over here we'd have a 52. But actually, if I undo some of this stuff, it's actually easier to do it from left to right because in modern society, at least for us, we all read from left to right. So it's actually it's actually easier. You can speed up your math by doing things from left to right. So if you do 1 times 4 first, you know that that's equal to 4. And then 2 times 4 is 8. So you get 48. You just do the math that way, and when you actually say it out loud, you say it that way, right? 1 times 4 is 4, so that's 40, and 2 times 4 is 8, so that's 48. You just read it out loud as do the math. I mean, we can change the numbers a bit. Let's say I put this as 22. Uh, yes, Jason, you wanna give this one a try?
I kind of disagree with that.
Okay, you disagree with that. Why so? If
Because imagine what if the number like four 5 like can I what if like 25 and then
okay,
4
25 times 4. That
like you
is
have
very
to this
valid.
is A but then
Mhm.
when
But then you
you have to
carry the
write
2.
0 then you have to
Mhm.
erase that
Uh-huh.
you have to go back and erase everything you have.
Exactly. Well, I perfectly agree with that. I see where you're coming from. I actually did mention if, for example, instead of a 22 or a 12, I put a 13 or a 3, where, carrying has to happen, it becomes a bit of a hassle. You have to go back and do some extra erasing. But
Everything you have to erase.
not everything necessarily, because
Almost
you will have
everything.
to carry anyways, right? If as you said, you did 25 times 4. Okay, 25 times 4. Even if you do it from right to left, right? You have to carry anyways. 5 times 4 is 20. You throw the 20 up here, and 2 times 4 is 8. But then you have to carry again. So even
Then
if
we
you
should
do it from
erase
right to
it.
left, you have to carry twice anyways.
But you don't need to erase.
Well, okay, it's
If
true you
you
don't
need
need to
to erase
erase,
it left.
but when you're doing mental calculations, you can just add the numbers up. The number when you say, for example, 8, you already know that 8 is over there. Because when you're writing the number out, you're writing it backwards. Okay. I'm not sure if that makes much sense, but you're writing the number backwards, and then when you read it, it kind of messes with your mind. Um,
But
you don't need if you want to stick with writing from right to left, that's perfectly okay. But just as a way to speed up your math, you could try doing it from left to right. Okay. If you
okay.
used to it, Jason, you don't have to do it. Okay.
It's like manga. Like the first time you read a book from left to right, and you have to
Yeah,
get
you can read it
you have
from
to
left
get
to right.
used to it. Get
Yes.
to it.
Yeah. Okay. So that was just on a little tangent over here. But let's get back to the lesson. Okay. Let's see. Uh, Apple. Well, whoever has like an Apple as their um avatar or name, can you change your name, please? Okay, Ryan, you can read the next part, starting with here.
Okay, the array of the dots of the left shows 4 times 10.
Mm-hmm.
The array of dots on the right shows 4 times 2. Now we can add the expression to find the total.
Mm-hmm.
4 times 10 plus 4 times 2
Mm-hmm.
equals 40 plus 8 equals 48.
Awesome. So we see both of these expressions, they were pretty easy to do, and you can just add them up to get 48. Let's do practice problem 2.
It's
So
6:45.
we have 9 times 4, right? And it's asking which expression shows the dots above the dotted line. And if you guys can't see the dotted line, it's the line that splits the blue circles and the green circles. I'll ask Ryan Lin this time. Apology to you, Ryan, but you just did read something. Ryan Lin, can you tell me which expression shows the dots above the dotted line?
Hmm.
So these are the answers. you can actually just count them, right? This is 1, 2, 3, 4. And from here, it's 1, 2, 3, 4, 5, right? So it's what times what? Or you could have counted the 5 first and the 4 second.
5 times 4.
5 times 4, awesome. So we see that the expression that shows the dots above the dotted line is 5 times 4. What about the dots below the dotted line? Without looking at the answers, Ryan, Lynn, can you tell me what it is? Can you count the green dots or find an expression?
So the green side,
The green dots, yes.
4 times 4.
4 times 4, awesome. So this one is also, it would be 4 times 4. And now we have 5 times 4 something. 4 times 4 equals total number of dots. What should this be? Is it addition sign, multiplication sign, or subtraction sign?
Adds.
Addition sign. Okay, let's check it. That is correct. And okay, thank you, Ryan Lin. I'll choose someone else. Sorry again, Ryan. Sean, would you like to give this question a try? Which expression can we use?
Um,
So if we look on the left side,
B.
you think it's B. Why would it be B?
Wait, oh, no, C.
C. Okay. So why is it C now? Why do you change your answer?
Because the side count 1, 2, 3, and then
Mhm.
it's 1, 2, 3, 4, 5,
Mm-hmm.
and then the other side is 1, 2, 3, and 1, 2, 3. So you
Okay,
have to
well,
add it up.
okay, but for B and C, I both see a 3, a 5, and a 3, and a 3. They look the same.
No, but for C, they have a adding sign, and for
Addition
B,
sign.
they have a
Yes,
multiple.
exactly. If you multiply it, it just goes completely off the chart, right? The answer is who knows how many. It's like somewhere in the range of like 180 something. So, or 90. If we check the answer, we see that this is indeed correct. Awesome. Okay, so we're done with the small numbers. Let's move into the big numbers. Who is brave enough to try the big numbers, or at least who's brave enough to try reading this section about numbers? Ryan, go ahead.
Working with large number. The distributive property is very helpful when multiplying larger numbers. Look at how can we use the stupid property
The
to simplify
distributive.
distributive
Mm-hmm.
property to simplify 15 times 8. We will start breaking 15 into 10 plus 5. Then we will distribute
Mm-hmm.
the 8 to both of these numbers.
Awesome.
50,
So
50
we see
times
15, we can break it into a 10, and we can break it into a 5, right? So 10 times 8, what's the answer? Real quick, anyone? 10 times 8, Ryan?
80,
And 5 times 8,
40,
40. So 80 plus 40 is
120.
120. Awesome. So we just tried one with 15 times 8. What about 18 times 3? How can we break it up? We broke it up over here. Someone already filled in a 10. So what should the other side be? Any volunteers? Ariana, would you like to give this a try? So we broke 18 times 3 into parentheses 10 times 3 plus something times 3. What would this something be?
8.
8. Okay, so we know that we can break 18 times 3 into 10 times 3 plus 8 times 3. How would we continue simplifying it? So what's the next blank? It's the same as 30 plus what? Or what is 8 times 3, Ariana? Ariana?
24.
24, good. And then, oops. So 30 plus 24, the final answer is
54.
54. Thank you. So the answer is indeed 54. I actually want to do a few more examples before we start our Kahoot. So you might notice, I'm going to skip the examples on the left for now because I don't think, whoops, we have enough time. But if we look at some of these examples, we can actually do something called factoring, okay? So what I mean by factoring, I should probably group these up with parentheses, is that we can do something that's like the opposite of the distributive property. So what do we see on both sides here? We have a 4 times 2 and a 4 times 3. So which number is common among them? Ryan?
4.
4. Okay, but we see a 4 on both sides. And we can, take a 4 out. We can go like, hey, there's a 4 here, there's a 4 here. I'm gonna take this 4 out of here. And what's left? We're gonna have what on the left side? Ryan, go ahead.
You mean
2?
me?
Yes.
2 plus
2 plus
3.
3. And what is 2 plus 3?
5.
5. So we have 4 times 5. 4 times 5 is just a use of our times table skills, which is
20.
20. Awesome. Thank you for the enthusiasm. Nicole, would you like to try this one? 7 times 7 plus 7 times 3. How do we solve this? So using the distributive property, what can you pull out of here? Nicole?
Wait, what do I do?
So using the distributive property, what number can you pull out of both of these expressions? So you see there's a 7 times 7 on the left side and a 7 times 3 on the right side. So try pulling a number out. What number is in both of them? So we can try factoring, that's what it's called. We can try factoring out a 7. Okay? So if I factor out a 7, that means it's like the opposite of the distributive property. Okay? So I take out a 7. What do I have on the left side? Before I had 7 times 7, I took out a 7. That means I still have, Nicole?
7.
7, and the left side, and the right side, sorry. 7 plus
7 plus 3.
7 plus 3. Okay, how would you simplify this? So what is 7 plus 3? Nicole?
10.
10. So we have 7 times 10, which is
70.
70. See how easy this was? If you tried calculating, I don't know, 7 times 7 plus 7 times 3, you get like 49 and 21, and you might make a mistake while carrying them, right? You might get like a 60 or an 80, but if you just do 7, you factor out the 7 and then add the 7 plus 3, the final answer will indeed be a 70. Okay, let's try this really hard one. Jason, can you try factoring out a number in this giant expression here? So what's the common number in both of these expressions? Jason? Or Ryan, since
Oh,
yes, Jason?
what did you say?
Can you factor out a number from both of these expressions? So you see there's an 11 times 49 plus an 11 times 51.
So are you telling me to solve it?
So what would be the first step?
510, 510, and 490.
It's not multiplied by 10, it's multiplied by 11. So
Oh,
in this case, the first step, because you see an 11 in both sides, you can take out an 11. Okay?
yeah,
So you factor out an 11, and what's inside? You have
49.
49. Okay, and
What?
you have
And
49 on the left
59.
and 50.
Oh, wait. Is 11, wait, just to make sure,
Mhm.
11 times 49 is 500.
You don't need to calculate it, Jason. You're not supposed to calculate it. You just you need to factor out the 11, which means you take the 11 out of both equations. Okay? So
Okay.
that's the point of the greatest common factor. So on the left side, you can take out an 11, and on the right side, you can take out an 11. So in the inside, all that's left is a 49 and a 51. Okay? So this simplifies to 49 plus 51. Do you see that?
Is
Yes.
100.
Exactly. So 49 plus 51, it's 100. And 11 times 100, it's pretty easy. What's the final answer, Jason?
1,100.
1,100 is indeed the answer. So instead of, I think you were trying to use your calculator or something to calculate like, oh, 11 times 49, and then 11 times 51, and you add them together, it gets
I
mixed
didn't use
up.
a calculator.
You didn't use a calculator?
No.
No, but there's a lot of chances for mistakes. I'm pretty sure I heard an incorrect answer somewhere there, but you can just
Yeah, I did. I said that. Then I like, oh, it's not. If I was 10, then like, oh, it's 11.
Well, if you just factor out the 11 and then add the 49 and 51, you get a 100 really
But
fast.
11 times 49, isn't it faster? Oh, never mind.
Yeah,
100.
it's complicated. So by factoring out the 11, you can see the answer really fast.
Yeah,
The
but then if
49,
you do
51,
11 times 49, you're like,
mhm,
11
like,
times 40 is 139 because
yeah,
1 times
it's very
9 and
crazy.
then 49 plus another 49, but you have to do that,
Yes,
which is 139.
right. It gets pretty crazy pretty fast. Okay, we have a few minutes left to finish
11
with our
is
Kahoot.
easier because you just need to add 49 and 49, but then the other 49 is in front a little, so it makes it easier if it's like 11.
Yes. Okay, so we have a few minutes left. Let's see if we can get everyone into this Kahoot before class is over. It is Halloween themed, well, slightly. At least the music is. And hopefully we can finish this over fast so you guys can get into your next class. Okay. Here we go. Give you guys all a minute. Okay, Sean, yes, you can leave now if you want. I'll see you next week. Bye, Sean. Okay, so if everyone is in, I will begin. And Garrus, if you could put your real name, I'd appreciate it. So I'll just call.
Oh, that's not me.
That's not you? Then who's top G? I'd like everyone to put their real name, please.
Oh, that's me.
Is that Ryan?
Yeah.
Yeah, okay. Well, then please put your real name. Okay, I'll start when you're in, Ryan. Okay, we shall begin. Okay, I think everyone got this one right. It is, we haven't learned functions yet, so it is greatest common factor. All right. The greatest compounded function is just something
It's
made up.
7 o'clock.
The others are also made up too. So the answer is greatest common factor. We covered this pretty early in class. Jason's at the top. Let's see the next one. Awesome. Everyone got this correct. Take your time. Okay, so I think the first person just rushed because it is not 3 times 4 times 5. But everyone else got it correct, so good job. Okay, I think this might have been a bit tricky, but the red, it was actually just a restatement of the original question without the parentheses. You might have noticed. But the correct answer is blue. You can simplify it. You see how it was really long before. After you simplified it, it just became a lot shorter. And you can actually compute it very easily. 2 plus 8 is 10, and then 10 plus 12 gives the answer of 120. Let's move on. Okay, Ryan's at the top. Okay, so this is true. Because 4 times 6 plus 4 times 3, this is the distributive property we've been learning all class. Don't just assume a statement is false because it's a true or false question. It might also be true sometimes.
I clicked wrong. I
Yeah,
clicked
44
on
is
the
not divisible by 8. Just saying. I'm skipping. Okay, so I see lots of people they thought 44 is divisible by 8, but it's not. 40 is divisible by 8, but 44 it's divisible only by 4 and 11. Okay, so tricky question, I guess. Okay, everyone should be able to do this one. All right, I guess we'll just skip. Okay, awesome. I'm skipping. Good. We're not asking you to compute the final answer here. It's asking using the distributive property. How you write it. Skipping. Hey, good job. Okay. All right. This did look a bit tricky, but if you know your times tables, 12 is divisible by 4, and 20 is also divisible by 4. So if you looked at, for example, I think it's the green one at the end here, you can still factor 2 out of both 6 and 10, right? So the correct answer was yellow. 4 times 3 plus 5. Both 3 and 5 are prime. You can't simplify them down further. So that is the answer. We have one last bonus question. See if you guys can do this one. Okay, would you guys like me to skip, or shall I wait for the last person? Okay, I believe I will skip. There it goes. Okay, so most people did get it right. It is 6. 16 is not the answer, because if you just do 3 times 10 plus 3 times 16, it's obviously going to be bigger than 3 times 16 itself. So the correct answer is 6. We know that 10 plus 6 is 16. So 6 is the correct answer. Let's look at the leaderboard. Drum roll, please. Jason in third. Aaron in second. And 11,000 points. Wow. We have Ryan in first. Awesome. In fourth and fifth, we have Ariana and Ed, respectively. So good job, everyone. I'll see you guys all next week. Bye, guys.
Bye.
See you later.
Bye.
See ya.